I'm here today to talk about Stratus Red Team and how we've used this to help tune and test our detection systems. Before we get started, there's a QR code here. All the slides are up already on my GitHub. Feel free to take a picture of it if you want to grab a copy of the presentation materials. I'll also have a picture of it at the end as well, so feel free to engage with the content and don't necessarily be behind your phone. So as mentioned, I've been at Secureworks for about 10 years. I'm a security engineer and researcher, and I'm on what's called the Detection Research Team in our Counter Threat Unit. And if the name of my team wasn't a dead giveaway, I'm frequently asked the question, can we detect this threat? And this could come from customers, partners, prospects, you name it, we hear it a million times a day. But a question that I'm almost never asked, but one that keeps me up at night and I ask myself more and more is the question, can we still detect this threat at some point in the future? And I think this question is worth asking because everything is always in flux. From adversary tradecraft and their infrastructure to our vendors and the software that they're providing to us, to our first-party parts of the security stack and our rule sets, everything is changing all the time. And the closer you look at all the different failure modes that can happen when there's some sort of security event, all the way to an alert is generated and it's actioned by someone in your SOC, there are so many places for this process to break down. Now, in a room of mostly software developers and engineers, you're probably thinking, it really sounds like you guys need tests. And of course, we do have tests, unit tests and integration tests. But what I'm here to talk about today is how we're using automated attacks for end-to-end testing, again, for our detection systems. So the purpose of an automated attack in the context of testing is to perform some activity, usually on an endpoint or against a cloud resource, that is repeatable and produces sort of predictable side effects that we can then use to calibrate and tune our sensing systems. We want to make sure that we see the activity that we are performing in our test case all the way through the pipeline from where it's actually happening, all the way to where we'd ultimately be doing sense making with it and, again, raising an alert. And this concept is not new. There are tools that are out there that are providing automated attacks and for end-to-end testing purposes for quite a while now. So a more well-known one is called the Marcotte Red Team. And this is a suite of end-to-end tests that you run on an endpoint. And these attacks are mapped to MITRE's attack framework, and it serves this purpose, again, for the endpoint. And if you look at Marcotte Red Team and what that project provides, there's quite a lot of complexity behind these test suites, how we build them, how we run them, how we would measure them. And when you think about how we'd apply some of these concepts for end-to-end testing against the cloud in particular, there really aren't any community agreed upon mature projects that have solved this problem yet. So back in January of this year, it feels like a lifetime ago already, a very passionate team at Datadog open sourced a project called Stratus Red Team. And the purpose of Stratus Red Team was to provide a similar function of allowing automated attacks for end-to-end testing purposes against cloud infrastructure. And the purpose of this talk today is kind of twofold. One, I'll share some details on what Stratus Red Team is and how it works. And then I'll go into some details around how we took this tool and utilized it at scale to actually, again, improve our detection systems, which ultimately is the goal. So since Stratus is designed to perform automated attacks against cloud resources, a natural place to start is, well, which clouds does it support? So at launch, Stratus Red Team had support for AWS and cloud-native tools like Kubernetes. But since then, the community has contributed providers for, in addition to those, Azure and GCP as well. And if you browse through the Stratus documentation, you'll see that for under each cloud provider, you're going to have some number of what Stratus calls techniques. But this is your catalog of automated attacks that the tool will perform for you that you can then use to, again, calibrate your detection systems. I'd like to highlight the Azure provider in particular. That's kind of partly why I'm here today. Secureworks contributed that part of the code upstream to the project. So if you have any problems with that, I'm the person to blame. So real quickly, we'll go through sort of how you would use Stratus Red Team. And again, you'd see how these components that I had in the previous slide kind of work together to make a really fantastic tool. And for this example, I will use a Stratus technique that is involving running what's called a VM run command on an Azure VM. And I like choosing this as an example technique because it's pretty straightforward in how it works, and you can understand why bad guys would want to do it. And the way this attack works is, if you spin up a VM in Azure, there is a control plane operation that allows a cloud administrator to run arbitrary code in either PowerShell or Bash as a system or root, respectively, on that endpoint. So it's pretty sensible why bad guys might want to do that too. If they can compromise, again, the control plane, they can then run arbitrary code on your VMs. So we're going to use that as our example here. So the first step to using Stratus is called the warm-up step. And with Stratus Red Team, and what makes it really unique is that the automated attack cases and the infrastructure that's meant to be the target or victim of the attack are very tightly coupled together. So the victim infrastructure is defined in Terraform, the same standard Terraform you would know and love from other cloud and DevOps stuff. And these templates for the victim infrastructure are actually embedded in as resources inside the compiled single file Golang binary that Stratus Red Team actually ships as. And again, these Terraform templates define what that infrastructure will be. So in the case of the VM run command scenario, that is going to include, obviously, the virtual machine resource in Azure, but also any of the other sort of cloud-specific minutia, like a managed disk, a virtual network, and anything else required for that attack to actually function. So once the target or victim infrastructure has been warmed up and deployed via Stratus Red Team, we then get to the detonate step. And this is where the actual attack is taking place. So inside Stratus Red Team, each technique has a very simple sort of API. There is a detonate function in Golang, which I'll show you in a moment. And these are always implemented in the Golang SDK for the relevant cloud provider that you are targeting with your automated attack. So in the case of the VM run command, this is an Azure specific attack. So we're using the Azure SDK for Go to actually perform the attack steps on the infrastructure we just deployed in the previous step. So here's a, I know, very hard to read example, but you can check out the slides on GitHub if you want to look more closely. But really, it's very straightforward implementations of the Azure SDK to instantiate basically the REST client to call that specific action on our newly provisioned VM, poll for it to be complete, and then finish. Extremely simple, easy to write, easy to understand. And then lastly, once the infrastructure has been deployed and then your automated attack has been run, critically, Stratus allows us to also clean up that infrastructure, effectively doing a Terraform destroy on what you just provisioned. And this is super important because we really don't want to be leaving behind infrastructure that's part of testing, especially when we're doing this in production environments where there's actually other work being done there. So it's really critical that you can clean up afterwards to restore whatever cloud environment you're testing in back to its original state. So that's kind of a whirlwind tour of basically how Stratus works. But what I'm going to go into now is, again, how we operationalize this from a testing perspective and performing the attacks, learning from what the outputs are, and then assigning this and remediating systems appropriately. So the first part of almost any automated attack for testing purposes is called detonation fingerprinting. And the purpose of this step is to basically collect enough metadata about the attack that you either are going to perform or just performed, so you can positively identify any side effects that that attack created in whatever environment where it happened, but also separate that from any other noise or activity that could be happening in the same environment. In other words, you want to positively identify the side effects of the attack and nothing else. Hence why we call it a fingerprint. So for Stratus Red Team, we did a couple of things extra to ensure we could isolate our different detonations of the technique. And that usually involved creating certain sessions that we could use for correlation later on, which I'll show you in a demo. And we also captured the state files from the Terraform that was used to deploy the victim infrastructure. And that's important because if you have things like randomly generated names for various resources, then we can positively correlate, again, everything that our test created and where and how we might find that or correlate that on some backend system like your SIM or your XDR tool. So that fingerprint step ultimately would output a JSON file, again, the detonation fingerprint or metadata file. And we would then take this as an artifact from our test, and we'd pass this on into a Jupyter Notebook-based script. And effectively, we read that metadata, read the fingerprint from our detonation, and we use that to co-generate queries that we could then use against our backend system to, again, find what those side effects really are, whether those are events or alerts. So I'll show a demo of this in just a moment. But again, the important part is that the Jupyter Notebook really is just taking the outputs from our fingerprint step for the purposes of correlation. So the data that we're trying to correlate, the side effects from our automated attack, boil down to, generally speaking, alerts or events. So for alerts, it's pretty straightforward. If we perform a certain attack, we should see a certain alert. We can then assert on that. Did we, in fact, see the alert when we ran this automated attack? Yes or no, right? We can link those together in a configuration file, basically to, again, have our mapping of what the expectation is from what was the reality. And on the event side, it's a little bit more complicated, but every detonation will have many side effects from CloudTrail logs being generated or process events for the affected endpoint. All of these things we want to collect and bring back. And then ultimately, for each iteration, which we'll get to in a little bit, we can then start diffing that telemetry to make sure that consistently we're seeing the same impact from the same automated attack on every part of the, basically the detection pipeline that it touches. One of the critical areas that we love to measure when we do these automated attacks isn't just the count of telemetry, alerts or events, but also the timeliness. Did we alert within the time frame we'd expect to make this actionable, to make this reasonable, or within some sort of SLO sort of time frame? So I'll show in a second, we have relatively basic analytics that we run. They're all written in pandas and Python, again, in the Jupyter notebooks, that take the telemetry we pull back in the previous step, and then sorts that and does a timestamp diffing so we can see where in the pipeline and how long did it take for each one of these sources to make its way through. And then once we have the fingerprint data, which we use to generate our queries, we perform those queries and bring them back into our Jupyter notebook. This step is, in my opinion, probably the most important of all, which is we're leveraging our native, we call an investigation feature, but you can think of it basically like a ticket in any of your other systems or SIMs that you folks are using. But we want to link all of these events, all these alerts, and the detonation metadata in one place that we can then use to assign that bundle of telemetry and events for that whole detonation to a particular team or individual responsible for whatever part of the detection pipeline may or may not have broken down, or we had a regression or something like that. So very quickly, here's a couple screenshots. We're not going to look at these very closely because I'm going to hopefully do a live demo or a recorded demo here in a moment. But ultimately, with the Jupyter notebooks, our primary goal is to have a what you see is what you get relationship between the notebook interface, whether that's in VS Code or natively or Jupyter Lab, and then our investigations interface in our XDR product. So what you're going to see in the VS Code and the markdown tables we generate there is exactly what you're going to see inside the investigation. And any of the pandas data frames containing the relevant alerts or events are automatically appended to that investigation. So it should be basically a close analog to a nice package of everything related to that detonation. So we're going to try this real quick. You may have to click play in the back, but here's a very fast 60-second demo showing this process. So ultimately, this is our JSON detonation file. That was the output from our earlier step doing the fingerprinting. We feed that into our notebook, where ultimately we're querying our backend system using that fingerprinted data. It's going to take a second to pull things back. I apologize for the whiplash. We then use Jinja templates that take the output from the results from our queries, generates our markdown text. So this is exactly what we saw when we ran our detonation. Again, kind of fast, but there's your time frames and everything from your attack. We save our notebook. We then create our investigation, uploading all of the related telemetry and the markdown you just saw. Should appear in the interface in a corresponding investigation. Well, again, what you see is what you get, and everything evidence-wise should be linked appropriately so that, again, this is something that everyone in our company, every engineer or researcher or analyst has access to, and we can simply use the built-in, basically task management components of our application to assign that to the appropriate team for remediation. And that's exactly what our next step is. So we ultimately will try to look at the output from our detonations, figure out, did we miss something? Was there a regression? Where in the pipeline did the failure happen? And then find the appropriate team. And we then just simply assign that to them inside of our investigations interface, or in your case, maybe your ticketing platform, your IT incident management system, whatever that might be, right? For them to actually fix the problem. But what makes automated attacks so compelling and so powerful for detection and engineering purposes is that you can then go back to that team and say, okay, you say you fixed it, prove it. Rerun the automated attack again. And when we generate our detonation and our investigation from it, we should see that the expectation now is reality, right? We now detected a threat we didn't before, or whatever, again, breakdown in the pipeline has been remediated, and we're now back to the known good behavior, the happy path we would expect for that detonation. So again, taking a step back and again, looking at this process at a high level, we would take Stratus Red Team, we would pick one of the techniques that we want to use for our end-to-end test. We would detonate it and create our detonation fingerprint of all the metadata, of the timing, the infrastructure involved. And then we would use that metadata to query our backend systems and bring back the relevant side effects. We can then do some sanity checking, make sure we're seeing what we would expect to see, bundle this up into an investigation, and assign it to the appropriate team if we notice there's an issue. And then lastly, we can again leverage that built-in workflow management component of our investigations tool to then archive it, which then tells everyone that they claim this has been remediated, this has been fixed. We can then redo the test. And that's really where I want all of us to kind of be going as a community, because ultimately, what we did once, and for the first several iterations in a very ad hoc way, we really intend, and we have a lot of progress towards actually being able to do this in a largely automated and CI-driven way. So we could run these battery of tests, 50, 60, 70 automated attacks, create 60, 70, whatever investigations from those, check that all of the expectations, again, are met, and then move on. And if we have any deltas or issues, assign it out, remediate it, and identify problems before customers do, before we miss a pen test, before there's an actual problem that we could have caught in advance. So this type of continuous and ongoing testing for detection engineering, I think, is critical and underappreciated at the moment. So a couple of lessons learned from this whole experience of ours. Firstly, and I think most importantly for the folks on like the Datadog team, Stratus Red Team worked super well. It really did fill the niche that tools like Atomic filled for the endpoint. Stratus really did in an exceptional and easy to use way for the cloud. And we did use it for testing in AWS and in Azure. And we did in fact find gaps and problems that had to be fixed from it. So I think its original and ultimate goal really was accomplished in our case. And I genuinely believe if you folks take it home and try to use it in your own environments, you would likely have a similar outcome. For our purple teams and other offensive research teams, having the API of the Stratus technique gives those teams an actual new kind of deliverable which is that, hey, you can provide this new end-to-end test case from your team, and we can use that to ensure that every other team is still aligned and able to detect that threat moving forward, which is a pretty big win. It means iterative and continual steady progress, right? And the investigations component, again, made it super easy because everyone in the company has access to it, knows what it looks like. It's not buried in a JIRA somewhere. It's not a CSV attached to a ticket. This is the way our customers would look at it. It's the way that we would look at it as researchers. It's the way we look at it as engineers. Some of the less good things we know we need to improve on. Our whole Jupyter-based automation worked super well, but it was still largely ad hoc. So we have a lot of improvement to do there, especially getting that to be entirely headless and CI driven. We're very close to this, and for sort of Stratus out of the box, I think we're very close. But that was one of the big realizations from this sort of battery of tests. And if any of you do end-to-end testing in your organizations, you're aware that any end-to-end test by nature is flaky. They're harder to diagnose when there are problems. So what we want our tooling to support is really make it clear how far into that detection pipeline did this automated attack go before there was a breakdown or a problem of some sort. So we're getting a lot better at that, and it helps us, again, assign which team is really the one responsible for remediating whatever the issue might be. And then the last point I'll kind of highlight is that we were running them in individual environments. They were production environments, but it was one at a time. Really, we'd want to be able to scale this up so that way we could run it across all of our production environments in all the regions, and again, start using all those additional test cases to cross-correlate with each other. Because as you guys are probably very well aware, even the same deployment in different environments are never actually exactly the same. So we need to verify, not just trust them. So looking forward into the future, I think this space in detection engineering in general has a lot of room to mature, and we have a lot to learn from the otherwise quite mature discipline in software engineering, where testing is taken much more seriously. We need to learn some of those lessons and really instill those in our processes. So I've been experimenting with ways of wrapping tools like Stratus, but also others, in such a way that security subject matter experts and researchers can submit not just some detection logic that they want to apply to all of our customer data, but also the test case that goes with it to generate and to validate. And until we have all three of those, right, the reproducibility, the actual logic, and the assertion, that's how we really get confidence that our systems are behaving in the way we would expect. So I'm looking to other much more mature projects in testing, like Gherkin, using behavior-driven development as a way to sort of make these test cases less onerous to write, and ultimately, again, encourage and get the researchers to contribute to the test suite, so it's not just an engineering concern. So you can really check out some of these projects that have been doing, again, similar work, in particular Gauntlet, which does this more on the automated and offensive side, but not so much on the asserting that we're seeing the telemetry after the automated attack has taken place. So to recap on kind of my main thesis here, end-to-end testing and automated attacks are extremely important to actually verify that our detection systems are working the way that we would expect. We trust too much, we validate not nearly enough. And I think Stratus Red Team is a really admirable project at moving us in that direction, and I really hope that the community will surge behind it and other tools like it, and this becomes much more common, especially for testing cloud infrastructure. And again, being able to bundle this up in the form of an investigation in our XDR tool was just super helpful, and it made it really obvious what the next steps were and how we could action it. So all in all, we will definitely continue to go down this route of end-to-end testing with automated attacks, and Stratus Red Team will almost certainly be part of that equation for us for the foreseeable future. So that's kind of a whirlwind tour there. I really appreciate your time, and I know that, again, I went really fast. Do you have any questions that I can help answer about our process or Stratus or anything else? In our case, because we are a security products company and we have a very mature and large research org, also our purple teams and offensive teams can write the test cases for us. So they're part of this equation that would drive the, what we're testing and able to test. Does that answer the question?
Question?
Anyone here actually used Stratus before or heard of it?
Heard of it.
Yeah, you're in for a treat, really. It's by nature of being that like single file Golang binary with all the Terraform sort of baked in, it really couldn't be easier to use. And in comparison to other automated test suites like Atomic Red Team, it's far, far easier to deploy and play with. So within an afternoon, you'll absolutely be able to get tests up and running and see what it looks like in your own environments, which is a huge win. Bar to entry is low. Yeah.
Sure. So, hello. Okay. So you chose like BDD programming to write your test. I guess like kind of curious why.
Yeah. So again, there's a tool called Gauntlet, which was it's an older project that also uses Gherkin and a BDD style test case to wrap offensive security tools. So specifically, it's like for each deployment, when I run Nmap and I run with these flags or whatever, then I would expect to get some result from my offensive tool, basically to make sure like, hey, is there a regression? Are we blocking the right ports? That kind of stuff. Ultimately, when I talk to my colleagues who are analysts or researchers, there is a big bar to entry getting them to write the test cases. And that could be in PyTest or whatever, but like writing them as fixtures is often hard. So just to get them in that mindset. So we're trying to find some kind of DSL that is generally flexible enough where they can kind of slap in more or less just the sort of, again, the expectation, and then be able to do that by configuration as opposed to as code. That's kind of the goal. And it's not necessarily the solution, but this is sort of the direction I would like us to kind of explore, if that's fair.
Yeah, because in my experience, like I've worked on a team where everyone was really excited about BDD, and then all of a sudden we all hated it. And we started reverting back to like actual code tests.
Absolutely. I mean, there's tons of gotchas and pitfalls there for sure. Again, in my little corner of the industry, even the idea that you have to ship any kind of test logic with your detection logic is still kind of a novel thing. It's not considered normal, and we need to do anything we can to make that as easy as possible to do. And obviously we'll iterate and try to figure out the best route forward, but in the very limited test or POCs and experiments so far, we have come up with some relatively flexible ways of using BDD and just Gherkin in general. I wouldn't even say BDD in the sense of like, in many cases we don't write those first, right? Which is kind of the whole point of really BDD or any test-driven development. But for example, you could have a Gherkin test case that says, on a Windows endpoint, when I execute X, Y, or Z commands, then I should see X, Y, or Z alert. And that's super trivial to slap in a nice DSL like a Gherkin or Cucumber or whatever, compared to trying to do that as actual PyTest fixtures. So that's kind of our goal.
Okay. And then one last question. I promise I'm not monopolizing. So like the previous question talked about like you have your own security pipeline, which essentially you said glorified cron jobs. Do you see value in having it run as the regular continuous delivery pipeline, especially when Datadog introduced like their way of using analytics to figure out like only running the tests that are necessary? So you're saving some of that time. Could you also include this as well in your? Absolutely.
And in fact, that was the first CI-driven Stratus Red Team test that we did was for a particular bespoke Apache Spark detector that was looking for certain behaviors for snapshot exfiltration, right? So I was looking for a combination of certain events, the occurrence of a certain account ID being used as what was being shared with over time. And when we actually ran the original test and we ran Stratus, it didn't detect it. We said, that doesn't seem right. This is a straightforward one. This is a fake account ID. You definitely haven't seen this in the past. What's the problem? And there was a problem. It actually wasn't with the logic. It was somewhere in how we were normalizing the data. But we found it. Like, okay, cool. That's useful. So then that engineering team took just that one Stratus test case, just one, not the whole battery, and not the whole investigation summarization stuff. They do run that as part of a CI test now because it's specific to that detector and it should always fire. So there are definitely different ways of applying a tool like this. It's not just a cron.
Cool. Awesome.
So,
Thank you.
yeah.
Any other questions? Oh, we got one right here.
Hello, me again. Does this hook into the previous question brought up before about Datadog and integrating with other Datadog services? Is there any, I guess, like way out of box to like hook this into a Datadog dashboard? Just something I can point to and say, hey, VP, this thing is red. This is the thing we need to fix. I guess that kind of thing. So
I'm not the one to tell you about how you would present this information in Datadog, but I can say, and I kind of, it is an omission not to bring it up, but Datadog also has open sourced a sister project for Stratus Red Team that's called Threatist, and it's a Golang-based test system that is purposefully designed to take Stratus output and check in Datadog data. So I would definitely point you towards Christoph in the back and the other members of the security advocacy team, because if it's not possible today already, this is absolutely the direction they are moving in, period. So you'll get there for sure.
Any other questions? All right, back here.
Thanks. And just to mention, so we have some stickers for the tool. So if you want to pick up one when you go out. Also, it's an open source project. So if you want to try it out, we have some issues that are also marked as good for first contributors. Feel free to pick them up, send us some pull requests. We are going to review them. And yeah, thank you, Ryan.
Yeah, I can't state enough how quite elegant the Stratus internals are. So if you're ever just curious of like, how would I do that in GCP for this attack, right? The code is very straightforward. It's a good introduction, honestly, to some of those SDKs you might not be familiar with. Give it a read over. You'll be pleasantly surprised at how straightforward it is, and other ways you can start extending it